Okay, so let's start. The first person said that we do question 1, Roman numeral 2. So they told me that we do this one, proving that A complement is equal to A. So that's the first one that we're going to start with. If you're ready for that, just give me a thumbs up so we can quickly start. Are we ready? Okay, let me just prepare a clean sheet that we can use. Okay, I think we can start from here. So the first question is saying that we need to prove that and how is the delay before I start talking? How long is it taking for you to see what I'm writing? Uh, and as I say things, is the delay that bad or is the network okay? Someone to unmute the mic and speak.
Okay, the network is just okay. I don't know about others, but the network is okay and what you're writing is very much busy.
Okay, someone else. Thank you for that, Jerome.
For me, the network is tripping and I can't see what you're writing.
Okay, how about the others? Others, is the network okay?
Guys, give us a response so that we know if we'll be moving on the same page.
Alright, okay. I think for most people the network is okay, so we can quickly move on. Okay, so how you go about solving this one is you solve it the way you solve the two De Morgan laws, but it's just that this one is shorter than those two De Morgan laws. And this question actually came, I want to remember the paper, the year, or if it wasn't the 2019, should be 2019 or 2020. That's when this question came, and I'd say that you need to prove it using arbitrary elementary method, which is just using the same method that you use for proving the two De Morgan laws. Okay, so you know that firstly you need to show that you need to show that a a complement is a subset of A, and again you need to show that A is a subset of A is a subset of A complement. So this is what you need to show. So starting with the first one, where we need to move from A complement and go to A, we use the same method as proving the two De Morgan laws. So you are going to say let X be a member of A complement. Okay, are we together on this point? So you say let X be a member of A complement. So if X is a member of A complement, this automatically means that X is not a member of A complement. Do I understand that? Or maybe there's someone that doesn't understand this. Okay, okay. I love the nine. Can I think that most of you are understanding this? And from this point, if a given element is not a member of A, so like we are talking about X, if X is not a member of A complement, and the type of set that you should be visualizing in your head is a set that is looking like this, where you just have A and you just have A and the Venn diagram, the universal set. Okay, it will be clearer when you visualize something that looks like this, so that when you say that if x is not a member of A complement, when we look at the Venn diagram that I've drawn here, A complement is outside this. Okay, so what we're saying is this is A complement. If X is not part of the outside, the outside shaded region, then it means that X must be part of what? X must be part of A. What is inside? So if X is not a member of A complement, that means that X is a member of A. Sorry, A, not A complement. Are we together on that point? Or I've lost someone? Okay, it seems I haven't lost anyone. Guys, if I've lost you, speak up so that tuendele pamoja. Alright, it seems that people have understood up to this point. So when you reach a papa point, that's when you say those things that you say that you've shown that what's this? That A complement is a subset of A. Then you move on to the other part. Where you are supposed to now move from A and go to A complement what? A complement. Okay, so when we come to this again, we can say suppose Y is a member of A complement. Oh no, what have I done? Not, we have already dealt with this part. Yeah, we need to deal with this part. Okay, so suppose that Y is a member of A. If Y is a member of A, it means that Y is not a member of A complement. If you look at the Venn diagram, let me draw it again so that we can be clear. We look at our Venn diagram here. There's just one set, it's just a set A. Okay, and we're saying that Y is a member of A. If we say that Y is a member of A, it means that Y is inside A. If Y is inside A, it means that Y is not part of A complement, because we know that A complement is what is shaded on on the outside. Are we clear? Okay, good. So now, if y is not a member of A complement, then y must be a member of A complement. Do you understand that? Okay, so Bianca, is it Bianca? Can we ask? Let me illustrate this. Think I'll illustrate this using elements. So if we take this set that I've written here, okay, and I put, let's say we have 1 here, we also have 2, and we have 3 on the outside, and 4. So we are saying that the universal set has 1, 2, 3, and 4. Okay, we are at this point. We are saying that A has 1 and 2. Okay, no, let me replace 1 and 2 with y, just y. Let me just replace this with y so that we follow along. So A just as y, okay, and we're saying that if y is a member of A, it means that y is not in A complement. If we were to take A complement of the universal set, we'll find that the only elements that we have is 3 and 4. Are we together? Okay, good. Now, suppose that A complement was equal to B. Okay? Imagine for a minute that A complement was equal to B. So it means that here where we have A complement, we replace A complement with B. Okay? Now, what would B complement be equal to? If we were to take B complement, what would B complement be equal to? Remember, the set we are looking at is the one mu universal set. So what would B complement be equal to if we say this is the universal set? Someone to tell me. Sharp guys, someone to tell me.
3 and 4.
Okay.
You know what I mean? B complement. You said B complement.
Yes, B complement.
Why?
At B complement would be equal to what?
Why?
Would be equal to Y. Okay. Does someone else have a different answer? Or we've all chosen B complement? We've chosen Y to be our B complement. So if we've said that Y is our B complement, now when we say that replace B with A complement, because we said that remember we said that A complement is equal to B. So where there is B, we can replace with A complement. You understand that? Okay, so if we were to say that where there is B complement here, apapa the B up, let's move the B. Who's that? Yes, who's that? Okay, guys, just give me a moment. Kumwayingira boss. Kumwayingira boss. Yes, boss. Girls. Nje vile niko fete amone fe mwenye ndi mu meeting so hapa. Amone fe mwenye. Yeah. Okay, guys. Okay, sorry for that. Can we continue? Okay, what I was saying was since we've said, remember we had b complement to be equal to just the element y, okay? And we said that where there is b, we can replace b with a complement, okay? Since we said that a complement is equal to b, where we see b, we can replace with a complement. So what I mean is, apart the b, we can remove the b and put a complement, okay? So if we were to do that, we find that a complement is equal to y, and a again pamulwapa, if you check on top here, a is equal to 1 is equal to y, even a complement is equal to y. Do we see that? Okay, so if we see that, then we can safely say that if y is not in a complement, then y is, if y is not in a complement, then y is in the complement of a complement, which is the same as if I put brackets, but it's still the same, okay? It's still the same thing. So it's still the same thing. I don't know if you guys have seen that from the relation that we try to come up here. So with the relation that we just made here, we can conclude that A is a subset of A complement. Okay, if there are any questions, you can tell me, or we move on. Guys, do you have any questions? Yes, Peter. Peter, I see an hand. Okay, guys,
Clear.
Yes, Peter.
I'm clear.
You're clear. Okay, that's good. Okay, I think we can move on from this question. So now when you reach this point up, that's when you guys conclude now to say from statement 1 and statement 2, we've shown that a complement is equal to a. I'm pretty sure you know that conclusion, what I'm talking about, when you reach this stage, because this is basically your statement 1, and this is your statement 2. So from these two statements, you can conclude to say a complement is equal to a. You've ended this question. So if we are clear, we can quickly move on to the next question on the list. Are we clear? We move on. Any questions? It's like Peter is the only one who is clear, guys. I did. I did.
Clear, sir. Clear.
All right, all right. Okay, I think we can move from this one. Let me go back to the questions list to see which one was the next question. Okay, number 2. Someone sent me number 2. So what we are going to do is, on number 2 here, we are going to do 1 or 2. So can someone quickly choose from these two, or from these 4, which ones we are going to tackle here, so that we move on to the next question as well? Yes, I did.
We can do the last one.
The last one? All right.
Yes.
Okay, let's do the last one. C complement. Okay. Okay, let me check it again to see if what I've written the correct things. Okay, yeah. So it says if C is a subset C is a subset of D. Well, let's see if we can simplify this. Okay, I'm hoping that we've all seen the question. The question is saying if C is a subset of D, then simplify if possible. So we need to simplify. We need to simplify this. So firstly, what we need to understand is what a subset. What a subset is. What we mean when we say C is a subset of D. If we say C is a subset of D, we can look at this example. No, it's not actually an example. It's actually what it's meaning, what the question is referring to. So if we have our Venn diagram like this, we have set D. If we say if C is a subset of D, it means that you've got D as the main set, and you've got C as a set which is inside D. So C is simply inside D when we say C is a subset of D. If it was the other way around, if it was D subset C, it would have meant that let me quickly draw up like a Venn diagram here. It would have meant that C was on the outside, then D was on the inside. We understand? Okay. Since we have understood that, what we need to do for us to to effectively solve this is fill in this example of a set that we have made. We fill it in with some elements. So I just say 1, 2, and 3. So 1 is both in D and in C, 2 is just in D, and 3 is on the outside of D and C. Once we do that, the next thing that we need to do is let's see if we can simplify this. We can simplify this one using the associative and distributive laws, but we're not going to do that. We're going to just use Okay, so as I was trying to go through the video and trying to see if there were any mistakes that were made in the online class, I stumbled upon this one. Okay, remember when we were finding this when C is a subset of D, we said that C complement has only 2 and 3. Then we said that D union C has 1 and 2. Okay, and if we take the intersection of these two, we find that we are going to just have the element 2. Well, we said that this cannot be simplified to anything else, but when you look at this, you find that if you were to take C complement, which was equal to 2 comma 3, and you were to take set D, which is equal to 2 which is equal to 1 and 2, and you take the intersection of these two, so you say C complement intersection D, you find that they are intersecting at 2 as well. So this will have the element 2. So we find that this is also equal to this. All right, and we can safely conclude to say that C complement intersection open bracket D union C complement or union C can be equated to C complement intersection D as its simplified form. Okay, so let's just be careful as we are simplifying. As you can see, this can actually be simplified. Pick another one from this same list. So we'll pick number 3, which says that you have C union D complement. See if we can simplify this one. So firstly, what we need to do is list the elements that are in C. You see that the elements that are in C, we just have 1. The elements that are in D complement, so D complement has D complement just as what? Just as 3. If we were to take the union of this, C union D complement would be C union D complement would be 1 comma 2. Can we associate this with anything? Can this be simplified? As in, what can you call this that is common? Can we say this is equal to, let's say this is equal to C complement? Or can we say it is equal to C? Can we say it is equal to D, or can we say it is equal to D complement? What we have here in the brackets, can we associate it with any of these? Okay, so we can't associate it with any of those. So we find that this also can just be left the way it is. Okay, it can just be left the way it is. Guys, may I need to find a question on this list that can actually be simplified. So I'm going to go back again. Let me go pick a different one. Let me pick which one. Between one and between Roman numeral 1 and Roman numeral 2, or we just do both of them? Okay, let's pick the first one. So the first one says you have C intersection D. We know what D has. D has 1 and 2. We know what C has. C just has 1. If we were to take the intersection of this, we find that they only intersect at what? At 1. These are only intersecting at 1. So we are saying C intersection D is equal to 1, just as the element 1. If we look at this, can we associate it with something? We find that yes, we can actually associate this with C. We find that C just has 1, even this has 1. So we can conclude to say that C intersection D is just simply equal to C. Do you understand that? Or I've lost someone? Okay, good. Let me also go pick the other one. Okay. The other one is this one. It says C complement union D complement. I hope I hope I haven't made a mistake. Okay, yeah, it's exactly like I've written it. So remember the Venn diagram that we have. If we go and pick, we take the elements that are in C complement. We find that C complement has 2 and 3. If we take the elements that are in D complement, D complement has just as 3, right? D complement just as 3. If we were to take the union of C complement and D, if we take the union of this, we find that we're going to have 2 and 3. Can we associate this with something that we have already listed? Guys, someone to give me an answer. Okay, someone to give me an answer. Someone to unmute his or her mic and give me an answer.
It can be associated with C complement.
Alright, yes, it can be associated with C complement. So we find that this and C complement are actually the same things. So we can say that C complement union D complement is equal to C complement. So we've simplified. We have simplified. Okay. So that's how you go about solving questions that when they ask you like this. That's how you go about solving them. Okay. Okay, so since we've dwelt on this one, we've dwelt on this one for some time. I think for the one for disjoint, we're just going to do one example. Okay, the one for disjoint, we're just going to do one example, then so the next one that we move on to is number number 3. And this one, they are saying that C and D are disjoint. When we say C and D are disjoint, it means that C and D are simply not connected. Okay, so if we were to write them in a Venn diagram, they would look like this. This would be your C and this would be your D. They are not connected, they do not have an intersection. So if we were to put some elements here, so we put a 1 here, we put a 2 and a 3 on the outside, find that there is no intersection with these elements. So once we have that set, let's pick one of these which we are going to solve for the disjoint. Can someone just quickly pick one up so that we can solve and see what other question we can look at? Okay, someone has said that we do the first one. Someone has said that we go for the first one. So the first one is saying you have C complement intersection D complement. Where is it? Okay, I've made a mistake. No, I haven't made a mistake. So if we were to write C complement, we would say that C complement is equal to, you get the elements that are not in C, and we see that in C we do not have 2, and we also do not have 3. If we were to get D complement, we can say that in D we do not have 1, and again we do not have 3. So the intersection of these two sets that we have listed, we find that they only intersect at 3. So you are going to have someone has sent guys, have I made a mistake? Someone just sent a emoji that is showing that maybe I might have made the mistake. Have I made a mistake? So we find that C complement and D complement only intersect. Alright, thank you for that. Thank you for that confirmation. C complement and D complement only intersect at 3. Okay, these are only an intersecting at 3, and we find that 3 is what is outside the non-can, what is outside set C and set D. And from this can only simplify to C union D complement, because if you were to take C union D, you find that C union D would be 1, 2. Okay, C union D would be equal to 1, 2. And if we were to take the complement of C, if you were to take the complement of C, union D, you'd find that the complement of the elements that are just not in this, will find that it's just the same three that we talked about. Okay, so we just find that in this case C complement intersection D complement can just equal to C union D inside brackets complement. It cannot be simplified to any other thing apart from this. What in I'll be done in about 20 minutes. Right, since we've understood this one, guys, I think we can move on, can we? Okay. Okay. So did someone send me number 4? Okay, guys, you guys who are left in the meeting, because we might be solving questions, then the people who requested for the questions are not even in the meeting. So you guys who are still here, can you tell me between question 4, question 5 and 6, which one maybe you said that you'd want us to solve, so that we can solve that one? Saying question 4 seems demanding. Okay, question 4, I don't know if that was a go ahead to go for question 4, or I don't know. Okay, so we go for question 4. Okay, so let's go for question 4. Okay, let me do this. So that I write this in advance. So we're saying we have okay, we're also going to do the second one from here, or we'll do these two. Okay, so let's do these two. So we're being asked to use the associative and distributive laws of the union and the intersection to simplify this. So mainly the law that I would want you to pay much attention to is this one. When you have A, let's say you have A intersection, you have A intersection open bracket B, union C. You can write this as A intersection B union A intersection C. Or if you have A union open bracket B intersection C, you can write this as A union B close bracket intersection open bracket A union C. These are mainly the two properties that we use when it comes to solving, when it comes to simplifying these types of questions. Okay, so these are mainly the two properties that we use. So if we look at the first question, which says that we need to show that this is equal to A. What we have here is equal to A. So we have A intersection B union open bracket A intersection B complement. So when you look at this, firstly what you need to identify is what is common. So when you look at this, you find that A and intersection is common on both sides. Okay, A and intersection is common on both sides. So it means that if you even check here from these laws, so you find that A and the intersection were common. And if A and intersection are common, they can be written on the outside like this. You can say A intersection on the outside, then you say open bracket. So once you do that, you move on in the first bracket here. You get the first element. So you see that the first element is B. So you put your B here. You get the symbol in the middle. So you find that the symbol in the middle is the union. You put your union. The second in the second bracket, you get the other element. Since we have already factored out the A intersection, the only element remaining is B complement. So you get your B complement. You write it like that. Are we clear? Are we all clear on that? Okay. So once you've simplified it like this, the other thing that you need to deal with now is you need to deal with A union B complement. So you need to deal with A union B complement. What is A union B complement? Equal to. So if you were to write a cassette like this, a Venn diagram, I'm not saying that you should do this in your test paper, no. When you're asked to use distributive and associative properties, you are not required to write a Venn diagram. I'm just using this for illustration. So you've got your set A and you've got your set B. So this, let's say this one has 1, we have 2 here, we have 3 and 4 on the outside. If we were to take B would be equal to 2, 3. If we were to take B complement would be equal to 1, because 1 is not in B, and 4 is also not in B. So if we were to take the union of B and B complement, you find that this is, you get all the elements. So you get your 1, put 1, you get 2 here, you have 2, you get 3, you have 3, you get 4, you have 4. Okay, so you find that what you have here has just scattered the entire universal what? Has scattered for the entire universal set. So in simple terms, what I'm trying to tell you is B union B complement is equal to the universal set. Are we clear? Okay, so what we can do is we can write this as A intersection, then here we will have our universal set, since we have replaced this with the universal set. Okay, now if we go back to our Venn diagram here that I've written for illustrative purposes, we have said that the universal set, which is being denoted by capital letter E, is equal to 1, 2, 3, and 4. It has these elements. And we get set A. Set A just has 1 and 2 as its elements. If we were to take the intersection of A and E, we find that they only intersect at 1 and 2. These are the only what elements that they are sharing from the set. Okay, so we can see that this is the same as this. Okay, so in short, we can simplify A intersection E to just be equal to A. Are we clear? Okay, so this just simplifies to A. All right. It just simplifies to A. So I think we've tackled this one. We can look at this other one. Okay, so we can look at this other one. So we need to simplify what is here to what is here. So let's start. So we have A intersection B in brackets union A intersection B should be B complement. Yes, it's B complement. Then union A intersection A complement intersection B. Let me see if I've written the correct thing. You might be thinking that you've written the correct thing, and I wrote something totally opposite of what's here. Oh no, yeah, it's correct. It's correct the way I've written it. So firstly, what you need to look at, you need to find things that are common. Okay, the way we did at first. So here I can see an A intersection here. I can see an A intersection here as well. But here we have A complement intersection. So let me leave this part alone first. Okay, let me leave this part alone. I'm going to pretend that like this part is not here. I'm going to do this, okay? And I'll deal with this part since it has things that are common. Okay, so what I'm going to say is I'm going to factor out my A and intersection and say open bracket. I'll have the first element in the first bracket that is remaining, which will be B. So I'm going to have my B. I'll have the sign or the symbol in the middle, which is U, and I'm going to have the other element, the other set on the other bracket that is remaining after we factor out A intersection, and that is B complement. So I have B complement like this. From the previous question, we already dealt with this part. We already said that this part is equal to E. Okay, we already said that this is equal to E. So we said that this will be equal to A intersection E. Okay, so from the other question again, we said that this is just going to simplify to A. I'm pretty sure we can remember that, right? Okay, are we together on that? All right. So since we have said that A is what is here, if you simplify it, we can take the A now to the part that we said that we are going to act as if it is not there. So in simple terms, what we are going to have is we are going to have A union open bracket A complement intersection B complement. Okay, so from this we can use the distributive property. We can distribute this to this, and again we distribute it to what? To this. So if we were to use the distributive property, we would say A union A complement like this. Then we will have this sign in the middle here, the intersection. So we have intersection. Then we are going to distribute this again to this. So we are going to have A union B. Okay, so we know that we know what A union A complement simplifies to. It is the same as having B union B complement, which we just simplify to the universal set. So this will be equal to the universal set intersection A union B complement. And whenever you take an intersection of the universal set with anything else, it will just be that other thing other than the universal set. So it will be this. So I can illustrate this using the sets again, but I know by now you understand that this is going to simplify. This is going to this is just going to simplify to A union B. Okay, we good? Okay, so I think this is going to be our last question, because we're already past 1 hour. We've done 1 hour 3 minutes, and I said that we're going to have this session for 1 hour. Okay, so I think we can leave it here. If there's any final thoughts, we can you guys can, if there are any questions,